physicist. Here we are with the data from the lab. Now, this is not the same tape that I showed you from the introduction video. And the reason why I switched it is because I already had this one marked. And so this was the same vehicle, same setup, same everything. And there was a little bit of a difference though. So I kind of learned from trial and error. You can see that there's seems to be this little weird pattern of dots as though the vehicle maybe had started moving, but actually that wasn't the vehicle moving. That was the ticker timer started to vibrate and it began to move backwards away from the vehicle. And so once I grabbed it, that stopped it, and then it started to put the dots down in the same place, and then I let the car go. So this is why this spot is so dark, and this is where our zero is at. This is where the true time equals zero, when I let the car go. It's a little bit hidden under this dot, but we're going to take it to be right here at the edge, and then we're going to start counting the dots going off in this direction. Now, one of the things that's going to be different is you'll see the pattern of the dots looks a little bit different. So you notice that the dots are very close together here at the beginning, but as I slide this farther and farther to the left, look at how much the gaps are opening up. So the markers that indicate the times, you can see, are getting more and more widely spaced. And the reason for that is because the car is traveling farther. It's accelerating. It's increasing its velocity in each unit of time. So because this thing will not accelerate for very long, I made one change compared to when we were looking at the velocity lab. And that difference is that I counted by every 3 dots instead of by every 6 dots. So remember, the ticker timer leaves a dot every 1/60th of a second. So in this case, where I want to kind of organize the data, I don't want to look at every dot. I want to organize the data. A logical choice would be every 6th dot, because that's 6 out of 60. That means 1/10. But because we're going to get so few data points, that means we'd only have 3 or 4 data points. And so to fill in some of the gaps, I decided to go every 3 dots, which would be 0.05 seconds. And so that's my first time marker after the 0. 0.05, 0.10, 0.15, 0.20, and so on. And so I have it marked so that we can make the measurement of the total distance. I'll place the 0 here on this 0, and we'll start reading off the numbers. And then I'll take that off, and I'll come back. And it's going to be difficult for me to do because I'm going to have to cover this when I bring the ruler up here. But I'll try to make sure it's clear to you which dot they were measuring. And we'll go and start measuring the 2-dot distance. And we're going to use that 2-dot distance to approximate the instantaneous velocity. The velocity at that particular instant in time. How fast was it moving at 0.05? What about at 0.15? What about at 0.30? What was the speed at that particular moment? And we'll use that 2-dot distance to make that approximation. So here we go. I'm going to give you the first measurement. We'll all have the same common measurement on the first one. And then after that, it's up for you to decide what you think the best measurement for that value is at each of the time markers. So let me get this lined up. Now, I know on the camera, it may not look like I have it lined up, and that is because of perspective on the camera. So when it comes time to make your measurement, I'll make sure to put the ruler in that particular dot as close to the center of the screen as I can. So I feel like if I were to slide that into the middle, let's see if I can get it in the middle there. There we go. That's pretty well aligned. Let me just double check. Yeah, I know on the camera it doesn't look like it's terribly well aligned, but it is really well aligned in the from my point of view, looking directly down over it. So what we're going to do right now is I'm going to get that marker in the middle, and we'll make this measurement together, and then we'll move on down the line. Let me just double check this. Make sure I got this lined up really well. Okay, feel pretty good about that. All right, here we go. I'm going to put 0.05 right in the middle of the screen. Now, for me, when I look at the 0.05, right, which is this guy, oops, right there, that looks to be slightly more than 0.5. So I would say 0.5, I would say that's maybe 0.56. I think it's maybe just a little bit more than the halfway mark. Now, if you disagree on that last number, that's fine. You can make that change. It's clearly somewhere near the middle between, 0.5 and 0.6. So you can use that to make your judgment call. Okay, now remember, we're measuring the total distance. So I'm not going to move the ruler. I'm just going to slide the whole thing over, and we're going to make our next measurement at 0.10 seconds. Now, for me, that definitely looks like it's a little bit short of 1.5. So I would say it was 1.4, and then you're going to fill in that last number. Is it right in the middle? Is it a little bit to the right of the middle? A little bit to the left of the middle? What do you think about that? Take a second here to make that measurement. All right, here we go, guys. I'm not going to tell you what the measurement is. I'm just going to let you know which dot you're measuring to and whether that dot is lined up in the middle of the camera. And I do apologize. I did make some marks on there accidentally. So let's see. This little mark right there is actually, I touched with the pen. So here's the 0.15 is this dot right there. And that looks to be definitely more than 2.5, but not quite at 3. So let me give you a moment to make that measurement. You should be able to give me 2 places after the decimal. All right, so now we're just going to move it right down the line. I'm just going to pause for a moment. When everything's lined up, you'll make your measurement. All right, that looks pretty good. And you're making your measurement to this guy right there. All right, so take a moment to make that measurement. I'm sorry, what am I saying? I'm so sorry, I apologize. No, the right on the time marker, right on the time marker. So it looks like a little bit more than 4. So go ahead and take a moment to make that measurement. And now on to 0.25. Get that guy close to the middle. Okay, so right there on the time marker, it looks like a little bit short of 6, but what is that exact measurement? 5 point what? Take a second to make that measurement. All right, on to 0.3. So let me get that guy in the middle. All right, there you go. Looks to be a little bit less than 8, but what's the exact value? 7 point. Make sure you're lined up with the 0.3 on your data table. All right, on to 0.35. Looks pretty well in the middle. All right, so that looks to be just a pinch over 10, but what's the exact measurement? 10 point. And lastly, 0.4 seconds. Total distance for 0.4 seconds. Looks to be a little more than 12. How much more? 12 point what? So I don't have that quite lined up. Let's try that. That might be a little bit better. If you want to adjust your measurement, that probably did make a tiny bit of an adjustment. This is kind of a thick ruler. Okay, guys, that's the total distance, right? And this video is available for you to go back and check these again. So if you need to go back and watch one, you can go ahead and do that. But now let's move on to measuring the 2-dot distance. This is how we're going to measure our instantaneous speed, because remember, that's the only way we can get instantaneous speed is to calculate it by using v equals d over t. So I'm going to really make sure to point this out to you as clearly as I can, which one we're measuring. You can see at 0.0, I cannot make the measurement because I can't see the dot before it, right? I mean, that's time equals 0. And this literally was when the car started moving. And unfortunately, there may be some ability to, if we could see all the dots, but there's probably about 150 dots in that spot. And so it kind of made this big blur that makes it a little tough to see the actual 0 point. So I don't know exactly where the dot is in front of that. So I'm going to skip ahead and just start looking at 0.5. I would anticipate that the car probably did have a little bit of velocity where I marked that 0. Okay, so I don't expect to see that the initial velocity was 0. I probably couldn't measure it because, again, I couldn't get that first dot. There's no way to see that very first dot. I'd have to really time the turning on of the car with the turning on of the ticker timer, and it never works. It never works. So I'm going to line it up. I'm going to move it out just a little bit down so that I can see it more clearly. I'm going to line it up for you. Again, it may not look like I have my 0 lined up quite correctly, but I'm looking directly down over the top of it. And now I'm going to put it in the middle for you. What you're measuring to is going to be that dot right there. Okay, so you see the time marker. I have my 0 lined up on the dot before it, and you're measuring the distance from that dot to this dot. That looks to me to be about 0.4 something. 0.49, 0.48. If you think 0.5, like it's exactly on the line, that's your judgment call, then you can say 0.50, but I would say probably 0.48 or 0.49. So that's the first measurement. We all agree on that first measurement. And now I'm going to let you make the measurement, and I'm just going to point to which dot you need to be measuring to. So it's a little more clear. I know it's a little hard to see once I get the ruler in place. All right. Now on this one, I actually darkened in the dot because it was a little bit too dim. All right, looks pretty close to the middle. We're looking at that dot right there. So that looks to be something 0.7 maybe, 0.7 something. You make your best estimate of that last number. All right, guys, on to 0.15. So I'll try to make sure that you can see where I'm getting the ruler lined up. So I already put little markers on there to indicate where the dot before and the dot after so that I could get it lined up more easily. Unfortunately, the only way I can do this is to cover it so you can't see it. All right, there we go. So 0.15, I'm gonna get the dot you need to measure right in the middle of the screen if I can. And this dot, I know I really apologize, there's so many dots on this piece of paper, but this is the dot that we're looking at right there. So still looks to be a little bit less than 1, but what's the exact measurement? 0. What? All right, that was 0.15. Now on to 0.2. Okay, the dot that we are measuring to is this one right there. This is the dot one after the 0.2. I got the other guy lined up on the dot before. Let's go ahead and make that measurement. All right, guys, let's slide this over to 0.25. See if I can line this up with the video camera. I think I could do it. Okay, that looks pretty good. Let's slide over to this dot. All right, so now we're looking at the dot after, which is this guy right there. You can see the distances are growing, right? Each of the 2 dot distances has been a little bit further than the one before. This is because the car is accelerating. So in each second, it travels faster, and therefore it travels farther, right? The faster you travel, the farther you travel. That's one of the relationships that we've looked at. All right, move this over. Let me get this guy lined up on the 0.3. Okay, looks pretty good. Move that dot to the middle. You guys are making your measurement to, sorry, this guy right there. So 0.3, the 2 dot distance is 1 point something. What's the last 2 numbers? If it's exactly on the line, then you want to finish your last number with a 0. All right, let's move on to 0.35. Put that to the middle, keep it lined up. All right, move that to the middle of the screen. All right, there we go. Looks like we're over 1.5 now. We're measuring to that dot right there. How far is that dot for the 2 dot distance? All right, one last one to measure. Remember, you can always go back and watch this later if it went a little too quick. Let me get that lined up for you. Okay, let's move that guy over. Not quite the 2, but getting pretty close. All right, and you are measuring to this dot right there. So it's 0.4 seconds. The 2 dot distance is 1 point what? All right, guys, that is it. So at this point, what you would want to do is you have your total distance and your time. You can go ahead and make that graph, and we'll talk about the trend line for that graph in class. You also need to make the velocity time graph, but you need to calculate that first. So you have 2 options. If you remember how to use the equation, then just do that in Google Sheets. Now, if you're having trouble remembering, you could go back and you might have put the equation into our last lab activity, and that was the constant velocity lab. So we use the exact same equation, right? The 2 dot distance is the distance that was traveled during 2 dots, and 2 dots represents 2/60ths of a second. So when you're calculating the velocity, it's always going to be the same calculation over and over again, and that's simply going to be the 2 dot distance divided by 2/60ths of a second. That is going to give you your V. Now, you could manually calculate it, but it wouldn't be so much better to let Google Sheets do the work for you. If you can figure out how to translate that 2 dot distance divided by 2/60ths of a second into an equation on Google Sheets, you can just let it do all the work for you. All right, guys, that's the data. Good luck with the analysis.